All right, so this week is the independent means t-test. We are going to learn how to do it in Jamovi. Just a quick review, when do we use an independent means t-test? We use this when we want to know about the difference between means of two different populations. So as we learned in lecture, we have two samples now, one from each population. And our hypothesis testing question is, are the sample means significantly different from each other? In other words, are the sample means different enough to conclude that the populations from which they have come likely have different means? Okay, so bottom line is we're interested in looking at if there is a significant difference between two groups of people, two separate groups of people, the between subjects design. To do this in Jamovi, we are going to use some data, and this is data that I collected from several past classes of statistics. I didn't do it with this class, but I did collect this data for a couple of years prior to this year. And I did this little experiment to answer the question, does the better than average effect apply to Redeemer students' religious attitudes? So what is this all about? Well, as you will probably know if you've taken social psychology, the better than average effect refers to this really well-known and well-documented finding in social psychology where people have this tendency to think of themselves as better, kind of the average Joe. So there's been a ton of research on this showing that, for instance, people tend to think their driving skills are better than average. Most people think they're smarter than average, more attractive than average, etc. This is a very well-known human kind of cognitive bias. So what I wanted to do was to take this and apply it to, as I said, Redeemer students' religious attitudes. So here's what I did for several semesters. I used my stats classes as participants, and they answered a short question, each of which asked about love for Christ. What I actually did was I randomly assigned the classes into two groups. And so I sent out an email to the class, but I actually randomly assigned half the class to get one link that took them to one survey and half the class to get a different link that took them to a slightly different survey or question. So one of those questions was that half of the class were randomly assigned to answer was, how much do you love Christ? And then the other half was randomly assigned to answer the question, how much does the average Redeemer student love Christ? Both questions answered on a scale from 0 to 10, higher scores meaning higher love. So my thought is, if the better than average effect holds, the group of students who rated their own love should be higher on average than the rating for the group of students who answered about the average student's love. Right, so that's my hypothesis. We are going to conduct a t-test for independent means to answer the question of, did students who were asked about their own love report a higher mean rating on the 0 to 10 scale than those who were asked about the average student's love? We'll use the 5% significance level, and we are going to use a directional hypothesis that people will rate their own love higher than the average student's love. And this is just because there's such a well-established body of literature on the better than average effect. I think we've got ample justification, research-based justification for using a directional hypothesis. So we'll have a one-tailed test there. All right. The results of the study are reported in the Jamovi file, which you are going to download to accompany these lab videos. And here is the file here. There's two variables in the data set. First is the 0 to 10 rating for love for Christ. This is just each person's rating on the 0 to 10 scale. And then this variable indicates what group each person was in, meaning did they answer the question, how much do you love Christ? Or did they answer the question, how much does the average student love Christ? And so you, if someone has a score of you, it means they answered the you question. And if they have the average student, it means they answered for the average student, right? So they're kind of in order. All of the U group comes first, and the average student group comes after. Okay, so everyone has a 0 to 10 rating, and then everyone has a variable indicating which group they were in, which question they answered. So let's conduct an independent means t-test to see if there is a significant difference between those mean ratings for the U group and the average student group. How are we going to do this? Let's go to analysis. So we're in the analyses tab. We are going to go to t-test, independent samples t-test. And here we move the rating into the dependent variables window, right? This is the dependent variable. It's the variable that we're kind of interested in looking at the mean differences between. So that's always known as the dependent variable. The grouping variable is the group or the condition that each person was in. It's how the ratings are split up. So group goes in grouping variable. We're going to click just a few things. The most important thing to make sure you get right is under the hypothesis window. So this is where you tell Jamovi whether your hypothesis was directional or non-directional, and if it was directional, in what way. And the default is to leave it at non-directional, right? Just that group 1's mean is not equal to group 2. That's not what we're doing. We do have a directional hypothesis. And to know which of these two buttons to click, we have to know which is group 1 and what's group 2. We know we have two groups, right? The U group and the average student group, but we need to make sure we know which one is which. And so the way that you tell which one is which is you have to kind of just go back to the variable information window, okay? And whatever group comes first in the levels window is group 1, okay? So the U group is group 1, average student is group 2. We go back here. Now we know that the correct choice for hypothesis is that group 1 greater than group 2, right? Because group 1 is the U group. And we're hypothesizing they're going to have a higher mean rating than the average student group, which is group 2. So that's fine. We're also going to click mean difference, effect size, descriptives, and the first two options under assumptions check, homogeneity test and normality test. Okay. So now we have this output generated, and it's going to be exactly the same as what appears on here. So like this information is identical to what's on the handout. I'm just going to move the handout to full screen so it's easier to see. So what you'll notice is that, again, as always, I've annotated the output for you. So for each number that appears in the output, I have a little description. Okay. So you can see, for example, there, number 1 is the t-statistic. That's the t-score for the difference between the two sample means, right? This is what we would figure on step 4 if we were doing it by hand, right? How many standard deviations from the mean is our sample result on the comparison distribution. All right, so that's what that tells you. We've got degrees of freedom, p-value, mean difference, all of it is there. And I encourage you to read over all of the annotations to make sure you have a handle on this output. I'm not going to go through it on the video here. It would be very boring, but please just read it over on your own time. What I do want to go over is how to interpret the results of an independent samples t-test from Jamovi output. This is pretty straightforward, like we're used to seeing. So the first thing that you want to do is look at the means for each group, and that is found in annotated output number 10. So let's go and look at number 10. Okay, and you can see here that each group has a row. So for the U group, their mean rating was 9.26. And the out of the 0 to 10 scale, and the average student group, their mean rating was 7.29. So we just want to take a look at those means and note, are they different from each other? How different are they? And yeah, it seems like the U group on average gave a rating that was about 2 points higher than the group that answered for the average student. So definitely a difference there. Make a note of that. And just like I note what these averages mean in terms of how the variable was measured. So that's what I was saying there in terms of, so there was the U group rating was about 2 points higher on the 0 to 10 scale. Okay, so that's what I'm talking about when I say note what these averages mean in terms of how the variable was measured. The next thing we're going to do is look at the p-value, because that tells you if that mean difference that we just noted was significant, given your significance level. Right, so I believe that we said we were going to do a 5% significance level. Okay, so 5% significance level, that's what we're comparing the p-value to. The p-value is less than 0.001. All right, so I'm going to write this out as always. So our significance level was 0.05. P-value is, it's less than 0.001. So whatever that would be, p-value is lower than the significance level. Therefore, our mean difference is significant. And this is just what we've always been doing in Jamovi, noting our significance level, observing the p-value, and if the p-value is less than the significance level, the mean difference is significant, or whatever result we're looking at is significant. So we know we have significant results. It seems like the group who rated their own love scored significantly higher than the group who rated the average student's love. It's really interesting that we get that better than average effect even for this domain of Redeemer students' religious attitudes. The next thing we're going to do is look at the effect size to see how meaningful the difference was. And as always, the effect size tells us the extent to which the populations of individual scores do not overlap, right? Higher effect size or a larger effect size means less overlap between the populations, which would be a more meaningful difference. The populations overlap less. So let's go and look at this. Effect size is where it usually is, just kind of at the end of this first table here. Cohen's d is 1.46. So we can use the guidelines from the chart that I've been providing in lecture to get a sense of how we would describe that verbally in terms of being a small, medium, or large effect. And if we were to go and look at that chart, okay, and I'm just going to pull up, this is one of the documents that we were using in lecture for the independent means t-test. And as always, this is the chart that I am referring to. Okay, so if we have an effect size of 1.46, that falls in the large category. So it's a pretty large effect. I'm actually surprised about how large this effect is. It's really interesting. So the final thing that we want to do is check to make sure the assumptions are met. All right, check to make sure the assumptions are met. Where do we find this on the output? We find the assumptions right here. The annotations give a very detailed description of how to interpret this. This is the same as we've been seeing before, broad strokes. Essentially, we have two assumptions for the independent means t-test. One is homogeneity of variance, which just means that the variances of the populations are equal. And one is a test of normality, that the distributions are normal. There's a separate test for each assumption that Jamovi provides to us. And all we are looking for is, you see each table has a p-value. Okay, each table has a p-value. We're going to stick with Levine's, just the top row here, top row. And we're looking at the p-value. And if the p-value is large, okay, that means if it is greater than 0.05, the p-value is large, then that means that that particular assumption, in this case, the one we're referring to right here, the homogeneity of variance assumption, that it's been met. Right? So if the p-value is large, it's a not significant p-value, then the assumption has been met. This is, again, kind of a weird instance where you want your p-value to be large. You want to have a not significant p-value because that means the assumption has been met. So our homogeneity assumption is great. It's been met. Now look at this. Here we are running into a situation where, so this table here is the test of normality. I'm just going to pick one line. We can look at the Shapiro-Wilks line and look at the p-value. It is a significant p-value, right? This p-value is less than 0.001. So that means that that assumption of normality has actually been violated. That means we are not dealing with normal distributions. And so when you get into more advanced statistics, you would, there's kind of other things that you could do. You might consider using a slightly different kind of test. But for the most part, when our N is as large as we have in this study, we generally feel confident that the test can still perform well, even if this assumption is violated. And we say that this test is fairly robust to violations, particularly when the N is large enough. And so for the purposes of this class, all I want you to be able to do is to be able to identify, using Jamovi tables, whether or not an assumption has been met. And that's just by looking at the p-value for the first row of each of these tables. And if there's an assumption that has not been met, then to just note it and say that, in general, these tests are robust to violations. So we're just going to proceed with the analysis. All right, so that's exactly what we are going to do. So we have done these steps, and we have determined that, yes, there is a significant effect supporting the better than average effect for the domain of religious students, Redeemer students' religious attitudes. The last thing we're going to do is estimate the power for the study. All right, so we're going to use J-power again, this time for independent samples t-test. And we are going to, this is going to look really similar to what we've done for the other t-tests, but there's one slight kind of complication with the independent means t-test having to do with if the two groups have unequal ends. So we'll do that. J-power, independent samples t-test. All right. If we want to calculate power, we're going to click on power, right? We want to get an estimate of how much power the test has. For a minimally interesting effect size, we're going to enter the effect size that we found in our study, 1.46. We're going to just leave the error rate at 0.05. We're going to change it to a one-tailed test. All right, but here's where we have to do a little bit of thinking. All right, so we're going to enter our N for group 1, okay, which we find in this descriptive table here, right? It gives us our N for each group. So just the way random assignment went, there were slightly more students who completed the average student question than the U question. So we just have unequal N's. There's 53 in the U group, which is group 1. Okay, so we're going to enter 53 in there. And then there's the cell that says relative size of group 2 to group 1. Okay, now if our N's were equal, we could just leave that at 1. Okay, that would mean there's like a 1-to-1 ratio for group 1 to group 2. And if we were to leave it at that, you could see here, it would assume that there were 53 in group 1 and 53 in group 2. But there's not. There's an unequal ratio. So how do we get the right number in this cell? Well, it's pretty simple. I'll show you how to do it. Pull out your calculator. And all you do is that you take group 2's N, so 58, and then you divide it by group 1 N. So 58 divided by 53, And that gives you a value of 1.09, round to 2 decimal places, 1.09. And you see now it adjusts appropriately, and it gives us an N of 58 for N2. And that's all you need to do. Now we have our power. Look at this. We had such a large N combined with such a large effect size that our power is 100%. That's fantastic. So we have great power. And because our power is perfect, we have 100% power. We don't need to then go and find out how many participants we would need to have adequate power. So we don't need to do that for this analysis, but for the assignment, you may need to figure how many, what if we needed to figure number of N per group to have adequate power, you would do it in the way that we have been doing for the other t-tests, right? So you would have your power at 0.8, leave the relative information of group 1 to group 2 size, you leave all of that, and it would give you the N that you needed for each group. Okay. And so that is power analysis, and that is the end of video 1.